Right. So we're going to try to do a couple more problems where we've got a minus sign at the end. It's the same process, but if you think back to those problems where we didn't have a number in front of the x squared, if this was a minus, you had to think when you're thinking about adding to get this middle number, you've got to think about really subtracting to get the middle number, right? And so that's kind of what it's going to be like here. That's the only thing that's going to be different, but we will have to think about the signs a little bit more. So, okay, here we go. Same thing. We're going to start by multiplying 9 times negative 14. Now, I'm just going to write 9 times 14, but that is positive 9 times negative 14. So I need to make a little note that that is a negative number. Y'all see? Of course, that just means when I look for my two numbers here in a minute, I'm going to need to look for numbers with opposite signs because they need to multiply to be this negative number. Everybody see that? Okay, so we're going to do the factor tree. We've got 9 and 14. 9 is 3 times 3, and 14 is 2 times 7. So we've got 2 times 3 times 3 times 7. 2 times 3 times 3 times 7. We need two numbers. They have to have opposite signs. One is positive, one is negative. We know that because they multiply to be this negative number. Everybody with me there? Okay, these same two numbers need to add to be this middle number, 15. Here's what we've got to remember. When you add numbers with opposite signs, you really subtract, right? And keep the sign of the bigger number. Well, we're supposed to keep this positive sign, so we know that the bigger number has to be the positive number, and the smaller number has to be the negative number, right? And of course, the bigger number has to be 15 bigger than the other one because we're supposed to subtract to get 15. So what are the numbers? What does your brain want to do if you're going to split those up into two numbers?
Mine wants to do 3 and 3 and 7 and 2.
That is one way a lot of people will want to do it, because we've all been taught to be like the mean girl clique in high school, where only the people like us get to be in our group. You know what I'm saying? So that is one way. There are definitely a lot of people who would think, oh, I'm going to put the 3s together, and then the 2 and 7 don't feel like they fit, so I'll just put them in a group together. If that doesn't work, what would be the next thing you might want to do? Just split them in half, like take the first 2 and the second 2. That works. 2 times 3 is 6. Now that's going to be the smallest number, so that one has to get the negative sign. And that leaves 3 times 7, which is 21 for our positive number. Well, won't those give me 15 in the middle? That's literally 21 minus 6, which is positive 15. So now everything else is exactly what we've been doing, but you've always got, when there's minuses down here, you got to be thinking about the signs a little bit, right? So 9 and 20, I'm not going to draw the lines and arrows, okay? Y'all can on your paper, but I'm not going to. 9 and 21, you have to figure out their greatest common factor. Greatest common factor of 9 and 21. 3, right? 9 is 3 times 3, 21 is 3 times 7. There's nothing that bigger than 3 that will divide into both of these. Then I need 3x at the beginning of the first set of parentheses. What do I need at the back end of the second set of parentheses? What needs to go at the back of the second set of parentheses? Would it be negative 7?
No, positive 7.
Positive, because It's whatever you multiply 3 times to get positive 21, right? Well, 3 times positive 7 is positive 21. Everybody see that? If this is 3x, what has to go first in the second set of parentheses?
3x.
3x? Because
3 times 3 is 9.
right, 3x times 3x is 9x squared. Y'all see? Okay, if this second set of parentheses ends with positive 7, what does the first set of parentheses have to end with? I hear whispers, but I'm an old man and I can't hear unless you say it.
Wouldn't it be -2?
It would be -2. Because remember, these two numbers have to multiply to be -14. So if this number is positive 7, do y'all see why this number has to be -2? Because those two numbers have to multiply to be -14. -2 times positive 7 is -14, right? That's it, it's factored. And if you took the time to FOIL that, you would see that when you FOIL it and combine like terms in the middle, you'll get exactly 9x squared plus 15x minus 14. Everybody see how this goes? Let's look at another one that's kind of similar. Again, notice this last number has a negative sign in front of it, right? And so you've always got to be watching for that, because when I multiply, I'm multiplying not 5 times 6, but 5 times -6, right? But I'm just going to write 5 times 6. But I am going to put a negative sign out here to remind me that it was positive 5 times -6, and that is a negative number. And remember what that means. It just means that when we look at our two numbers in a minute, or look for our two numbers in a minute, again, they're going to have opposite signs. Do y'all see that? So we've got 5 and 6. Well, 5 is already prime. I can't factor it more. 6 is 2 times 3, right? So I've got 2 times 3 times 5. 2 times 3 times 5. I need two numbers. One of them has to be positive and one has to be negative, because y'all look, they multiply to be negative, right? Okay, those same two numbers have to add to be -13. When we add numbers with opposite signs, remember we really subtract. And we keep the sign of the bigger number. So do you see why this time our negative number needs to be bigger?
So it would be +3 and -10.
Well, is 10 minus 3 equal to 13? So remember, these numbers have opposite signs. You're not going to actually add to get that number. You're going to subtract to get that number. Aha. Well, what if the 15 was the negative and the 2 was positive? Do y'all see why the 15 has to be the one that gets the negative sign? Because remember, we keep the sign of the bigger number. Well, which sign do we keep? The negative sign, right? So do y'all see why the bigger number has to be the negative number? And so if this had been plus 13x, it would be -2 and positive 15. Y'all see? But you can see 2 minus 15 is -13, right? So that's the correct middle number. So now we've found the two numbers we need. Now we've got a factor. Now, I'm glad this one came up because there's a little thing here that's so easy it might be hard. You've got to look at 5 and 2 and figure out, I'm going to go ahead and draw the lines this time, even though I said I wouldn't. What is the greatest common factor of 5 and 2?
1.
1. Thank you. It's 1. Does everybody see that? That means that here at the beginning, I need 1x. Of course, I don't really have to put the 1 there, right? I mean, 1x is just x. But I'm going to put it there just so we can see where it came from. That's the greatest common factor of 5 and 2, right?
I have a question. Whenever you define the greatest common factor for the 5, or just a single number like that, you never use the 1, you just use the 5? Because can you multiply 5 times 1 to get 5?
Yes, and you can multiply 2 times 1 to get 2. So 1 is the factor that's common in both 5 and 2.
Why didn't we have it up there, the 1 up there? With the 5?
Well, you can always do that, right?
Oh, but it'd be the same.
Yeah, you can always do that. So y'all listen, because there's actually a good question in here. There's a good thing to point out. She's asking, well, why didn't we have the 1 here? Because 1 is a factor of this number, right? Everybody see what I'm saying? Because it doesn't matter, except there are times it does matter, because what if it turned out that whatever this was when we tried to factor it, what if it turned out that we needed to take all of these numbers together for just one number? We could do that. That would just automatically make 1 the other number. Y'all see that? So that 1 is always there, but 1 is a factor of everything. And we usually think of it as a trivial factor because if you multiply it times something, you just get the number you started with. You see what I'm saying? I'll try to show you an example in a minute where it might be important to think about the fact that there is a 1 here, but we don't generally need it. All we're doing here with this 1 is saying, look, the greatest common factor of 5 and 2 is 1, right? 1 is a common factor of everything. So there is no common factor between 5 and 2, which means 1 is its greatest common factor because 1's a factor of everything. But 1 will generally be the smallest common factor, right? Unless it's the only common factor like it is here. Y'all see what I'm saying? Okay, if this is a 1, what goes here?
A positive 2.
Very good. She said positive 2. Because remember, it's what do I multiply? What do I multiply 1 times to get 2? Well, that's 2. Y'all see? So like I say, when you get this 1 situation, it's so easy, it's almost hard because you're not expecting that. Y'all see what I'm saying? Okay, at any rate, if this is 1x, what has to go here? Y'all see? 5x? Because remember, those have to multiply to be 5x squared. If this is positive 2, what has to go here?
Negative 3. Right?
Because those two numbers have to multiply to be negative 6. Do y'all see that? Then it's factored. It's 1